Welcome everyone to IMESH. Today, our webinar is Securing Multi-Cloud Microservices with Istio Part 2. In the Part 1, we spoke about how to secure two microservices using a stronger identity like mTLS. Now, there was more and more demand to cover services which are spread across clusters and across multiple clouds, and how to secure the communication between these two services. So that's why we came up with this topic. And the speaker of this topic is Ravi Verma. He is the CTO of IMESH. Now, Ravi Verma has near about 12 years of experience in software architect, and he has led many teams, R&D teams for companies like GE Healthcare, Baxter, Ericsson, Samsung, etc. So a bit of housekeeping. We are recording this webinar, and we'll send you the recording after this webinar is over. During the webinar, if you have any questions, please feel free to ask or put your questions in the chat box. Towards the end of the webinar, we'll take questions one by one and we'll try to answer them. If we are not able to kind of answer your questions because of time constraint, then please feel free to shoot your questions at contact@imesh.ai. All right. So a brief about us. We formed IMESH in 2023. Basically, we went out of stealth mode. Our headquarter is at Dover, US, but we have an office at Bangalore, India as well. We started IMESH with a simple mission to simplify and secure the complicated network of microservices in the cloud and Kubernetes. As of today, we have two offerings. First one is we provide enterprise support for open source Istio service mesh. So if you are looking for any consulting services or implementation services, ongoing maintenance support, then IMESH can help you. Then we also provide IMESH Istio dashboard, which is a proprietary solution by IMESH. It's basically a visibility layer which you can plug it on the top of Istio service mesh to provide detailed visibility into your traffic across multiple clouds, across multiple clusters. So that's it. And now I will hand over the discussion to Ravi. He can take the discussion forward. So Ravi, over to you.
Thank you, Devrasi. Hello, everyone. Good morning, good afternoon, good evening. Without wasting any time, let's jump into our agenda. We'll start from there. So I'll share my screen. I hope my screen is visible.
Yes.
Thank you. Okay, so in our previous session, we had discussed around like what is service mesh and how it can be used to secure communication between microservices and across like within the cluster or even beyond the cluster, like multi-cluster or multi-cloud. It can go anywhere. So in today's plus, we discussed case study of like what all like who and big players are using the Istio service mesh. In today's session, we'll be discussing about how to configure Istio for multi-cluster and multi-cloud, and how to secure the communication between microservices. For that, we'll be configuring two clusters. One is GKE and another one is AKS. So Azure AKS will be configuring as well. After that, we'll deploy application. We'll start communicating. We'll fire the communication between those two. And after that, we'll enable authentication layer and like a few authorization policies will apply to see whether where and all we can restrict, basically to have a granular control over it. Fine, so let's go ahead. Okay, so this is our goal basically. At high level, what we can see is one cluster is there in GKE, Google, another one is in Azure, that is AKS, and we want to basically establish a communication between those two clusters, plus those communications need to be secured so that like we can transfer any sensitive information as well. Before going next, we have like basically we have a security challenges at mainly 4 places. We have to look into it, and at different levels we kind of encounter and try to solve that problem. So it is 4 C's of container security. One is at cloud level, then it comes to cluster level, then it goes to container level, and after that it goes to code level. So by using only code, we cannot mitigate all the security challenges. So that's where all the places, all those 4 C's, we need to tackle the security challenges and make our network hardened so that it is very hard to break. Fine. So this is our goal. We'll be starting implementing it, and after that, how it looks, after that we'll see, like after installing, how it, like we will try to visualize what all the things we have done and how it is looking now. So let's start with our implementation. Okay, so I hope my Visual Studio is visible. We'll start from here. So as I mentioned, we are using 2 clusters. One is GKE and another one is AKS. So I have configured to, like, we'll be using those two, like we'll be trying to communicate within those 2 clusters again and again. So for that, I have to make it like less typing. I have configured an environment variable, 2 environment variables to set the context for those 2. One is GKS, another one is AKS. So that we can see here, just we can see what I have done. So echo, I'll just print it out so that we know. So one is AKS, this is AKS context, and another one is GKE. In our today's session, we will be configuring multi-cluster, multi-cloud, basically multi-cluster on multi-cloud with different network, because we cannot configure the same network for the 2 different cloud providers because they will have a separate networks. So definitely we need to go with 2 different networks. So we'll make GKE as a primary like control plane, and AKS will be a remote cluster. So let's start. So first of all, we need to configure our primary cluster. So for primary cluster, we need to create a YAML file. Like we can do it using command lines, but to avoid a lot of typings and all, what I have done, I have created a YAML configuration file directly with all the required details so that we can directly apply and it will create. Okay, so few of the things I'll mention here. We have added this external Istiod. So this is used basically to tell this control plane also has capability to control remote cluster as well. So basically it will take control of the other remote cluster which is getting added to a cluster, like the control plane. It acquires a lock on that and it works as a kind of I'm the controller. So that's the flag this is used for. Another flag, if you can see, it is privileged. I have added basically it will be used to get a root access for our proxy container. So it is not recommended for production. It is only for demo because I want to show something, the communication related thing that we'll see later. For that, I had to enable it. We are creating, as I mentioned, we have 2 networks. So the primary cluster will be on network 1, which I have written here. Cluster name is GKE cluster. It is cluster GKE, and the mesh ID, like complete mesh, will be a name. The name is mesh 1. So for that only we need to apply it using Istio-ctl. So we need to install it. Istio-ctl install. As I mentioned, we are making GKE as a primary, so we'll use that context. env GKE, and then we can give the file. So it is cluster GKE primary. So it will install our Istio on GKE, and it will make as a primary cluster. So let's wait for few seconds. It won't take much time. So once it is installed, so basically we need to perform few steps. So one is installing the Istio. The second one will be installing the gateway to communicate between those two clusters. We need to expose the services so that it can be accessed cross cluster. So similar kind of thing we need to do on the second cluster as well. So let's wait, it won't take much time. So Istio core installed, Istiod installed. Now it is processing ingress controller, it is installing. And after that, it will be done. Yeah, yes, so it is done. Now the second part we need to do is install east-west gateway. So the gateway is basically used. It is a kind of entry point for the another cluster to enter into the primary. Like there will be a gateway which second cluster like AKS cluster will be entering, like contacting that gateway to enter into or talk to the control plane. So for that we need to install our gateway. So for that we again will do Istio-ctl install again env GKE. It's a primary, our main control plane, primary cluster. We need to give this file, second file is west gateway. So as we mentioned, it is coming under network one. We'll be exposing this. So let's give it installation GKE. We need to wait. It will create a east-west gateway load balancer as well. And we need to wait for that IP because that IP we'll be using to configure our second cluster, which is a remote cluster. So that is the IP on which that remote cluster will be communicating or contacting. So we need to wait and see when it is assigned, then only we can proceed further. So let's check kubectl get spc Istio-system and our env. It is GKE. Yes, so it got external IP. We need to copy this and we'll be using to configure our second cluster, basically. Okay, so this is done. Now we need to expose our Istiod service and all the services so that the second cluster can access that via our east-west gateway. So for that, we need to expose that. So let's apply that kubectl. So the exposing is nothing but creating a port so that it can be accessed via like from the outside. And it is that communication currently that IP we saw, it is a public IP, so anyone can access it from the outside. But in production, it is required to be secured via like various means. We can secure that one using HTTPS, like we can have certificates, we can create our firewall rules to restrict that access. So in the production that we need to do. So kubectl apply env GKE and we need to expose basically. So expose, we need to both Istiod and services. So no need to worry about the files at the end also and explain, and even we'll put this file in our GitLab repository so you can access it from there. And services. Services. Fine, so we are done with setup of our primary cluster. Now it is time to configure the second cluster, which is a remote cluster. So that will be doing in our AKS. For that, this is the file. This is the configuration. It is profile remote. This is the injection path we are using currently. This is not recommended for production. Instead of this, we use injection URL, and that need to be configured on secure channel, basically, But for this demo, we'll be using this one so that it is easy to demonstrate. The IP which I was mentioning here, that East-West gateway IP, that we need to mention here so that second cluster can communicate to our primary cluster. So this is the IP I have put now, and it is ready to be installed. And the same flag privileged, I have again made it true so that we can get root access for the proxy containers that we'll be using in some time. Let's go ahead and install or configure our second cluster. For that, again, we need to do Istio ctl install. This time it will be AKS, our env. So AKS will use file as cluster remote. AKS remote. Okay, so before that, we need to prepare our namespace. Basically, namespace, we need to create a namespace. We need to configure. Basically, we need to apply a few things. We need to apply a label. We need to annotate it in a second cluster so that it can get control, like basically the first controller or the main primary cluster controls the second one. So for that, we need to apply few annotations. So this is the annotations we need to apply on the second cluster. So what we are telling here, for the second cluster, GKE cluster is the main controller. So cluster GKE is the controller or a control plane, and this is a remote plane basically. And this need to be labeled with the network 2. It means it is on another network, which is we are calling as a network 2. So this need to be done as a pre-setup. So before installing. So let's do it. First, kubectl env AKS and this cluster AKS preparation. So basically it will create a namespace, Istio-system. It will label it, it will annotate it. Basically it is preparing for our next installation. That is done. Now we are ready for installation. So I'll just copy it again from here. Paste it, and we are good for installation. Yes. It won't take much time, only within few seconds it will be done. After that, we have a very crucial step that need to be done after this step and before any deployment to a second cluster. Because what happens if we don't do that one, then certificate patching and all, it won't happen. That's the thing when we deploy a workload into the second cluster, that time it need to get the certificate, mutual certificate from the Istio, but that will not happen until we perform the second step. So that the next step is basically we will be creating credentials which will allow cluster 1, which is GKE cluster or Istio running on the GKE to control the API server, basically get the access to API server so that it can do the service discovery and it can patch the webhooks and all. So that is required to access that. So for that, we'll be creating a remote secret, and we'll apply that remote secret to our first cluster, so which is GKE cluster. So let's go ahead and do it. For that, we need to fire this command istio-ctl x create remote secret. Okay, and we need to give a cluster name. What's the cluster name? So in this case, our cluster name is cluster AKS. So this is the second, this remote cluster name we need to give. And this we can take it in one of the files. So I'm just naming it API server creds aks.yaml. And this this created file will be applying into the cluster 1, so that the cluster 1 can get access to API server of 2. So this file is created. We can check the content. Basically, it will have the URL, it will have IPs, and it will have 1 minute. Okay. This is coming for the first cluster, as we didn't mention our for which cluster we are running. So Envoy AKS. Yes, so we can see it is for cluster AKS. It is having cluster endpoint, API server endpoint, and it is having few related information so that the cluster 1 can access the cluster 2 API server. So let's apply it in cluster 1. So kubectl apply. Oh, something is wrong with my keyboard. Apply. Again, we need to do it in the first cluster we set, which is GKE primary cluster. If an app API server, we need to apply. Okay, so what happens, as I was mentioning, once we apply this one, the cluster 1 or Istiod running in a cluster 1 primary cluster will try to access the API server of cluster 2, which is a remote server, and it will send all required information, and it will prepare, basically it prepares the cluster 2 to be ready for other next deployments for Istio. So let's do it. This is done. Now we are ready. Like whatever we did in cluster 1, like we created east-west gateway, and then after that we exposed our services and Istiod. As Istiod is not running on cluster 2, only services, so we'll expose services on cluster 2 as well. So let's go ahead and create our east-west gateway now. So it's Istio-CTL. Now we are ready to create that. Otherwise, if we would have done this step before applying the credentials, it would be not working. It will basically raise the error for the certificate, some unknown certificate error. Istio install. Okay, again env, and this we are running in AKS, so this one. And file we need to give is the second one. So let's have a look a bit. So as we are mentioning, it is running in network 2. So we need to configure it as a network 2. And we'll give this file AKS. Yes, go ahead. It is installing our east-west gateway in cluster 2. How it looks like after this one, I'll show an image and we'll explain. So nothing to worry. Fine, now it's time to expose our services. So kubectl by env AKS, and it is expose services we need to do. Fine. So now it's ready. So now our, like both the clusters are ready for communication. They are ready. So it's kind of, we have done, our battlefield is ready now. Now we need to deploy a few soldiers and we see them in action. So it's time for deploying the soldiers. So before go to deploying the deployments, let's see how it looks now. Okay, so this is our GKE first cluster, which is primary cluster, which is running in network 1. This is second one, which is AKS, running in Azure. It is running under network 2, and it is cluster 2. Here, this API server in the cluster 1, which is a primary cluster, it restores the configuration and endpoints as well. This Istiod needs access to second API server because it needs to discover, basically for discovery services, discovery of the services need to be done. Like when we deploy any services in cluster 2, Istiod need to know what all the services has been deployed here, so that if it is any one of the services, they're falling under Istiod control, like namespace, which is enabled, so that it can control that, or basically it can inject the proxy inside that. So that we did in the first step when we configured. Second thing is gateway. So when we were configuring gateway 2 here, that time we gave a IP of gateway 1 here. So that this gateway 2 can be configured. So this is the dotted line. All the dotted lines we are seeing is a configuration dotted lines. Okay. Now let's go ahead and deploy our application, and we'll start communicating. Fine. So for this, we will be creating a service and 2 deployments. One deployment will put it under cluster 1, another one will put it in the cluster 2. Then we'll start cross cluster communication between those two guys. So let's go ahead. It's a simple service, nothing else. It is the name of the namespace I'm giving is a multi-cluster. So I'm already giving injection label here, so that we need not to type it in the terminal. So all those things will be done when we apply this label. And this is one service which is running on port 80, and the target port for which it is targeting, it's running on 5000. So let's go ahead and apply these two in both the clusters. So kubectl apply env. So let's first apply in GKE. Okay, so all the services need to be deployed in both the clusters, so that it knows like where and all workloads and services are there. GKE demo service. GKE is done. Now the same thing need to be done for AKS as well. Something is seriously wrong with my keyboard today. Fine, service created. Now we will be deploying our application after this. So let's go ahead. So here I have given a name. Deployment 1 is for cluster 1. Deployment 2 is for cluster 2. So let's go ahead and deploy it. So here demo deployments, it's version 1. Basically, when we get the request, it should be coming from the version 1. Then we'll come to know it is coming from the cluster 1. So let's apply into GKE. Second one will apply in AKS. Fine. Now, as we have deployed our application, we'll be deploying 2 more applications or the pods basically, so that we can initiate a request to these 2 deployments or these 2 services. For that, we'll be applying a sleep deployment into both the clusters, so that we can fire the request to both the endpoints basically. So let's go ahead and apply that. So sleep, it is for AKS. Let's deploy here. Okay. And the second one is GKE. We should go to GKE. See? Fine. Now it is time to check the communication between those 2 clusters. So let's have some information. So let's enter into one of those sleep containers so that we can fire a request. So kubectl, let's just check the ID of that currently. Get pods. It is multi-cluster and env. So first one is GKE. So these are the 2 deployments we did already, we saw, and this 2 means that one is the actual container, second one is the Envoy proxies injected by Istio. Same thing to be present in AKS as well. Let's verify. Fine. So I'll be entering into one by one, like one time into this one and another time this, and we'll fire a request to a service, this service, which is we export, and that service is basically controlling those two deployments running in two different clusters. So let's go ahead first and check the GKE one. So for that, give ctl exec-mighty name. We need to give our env GKE. It's fine, and it is multi-cluster, and we need to give the command. Fine. So as we can see here, the name of this service is hello world. So we'll be accessing this hello world with port 80. No need to specify any port. By default will be 80, and we need to send to hello. We need to send a request. So let's go ahead and do that. So we'll do curl and hello. Sorry about this. Hello world. Hello. This is coming from version 1, and version 1 we had deployed in GKE. Let's go ahead and send second request. So if we see, if we are sending the request fast enough, we'll be getting the request and response from both the services. Okay, perfect. So from GKE, the first cluster, we are able to access both the deployments. One is in AKS and another one is GKE. So the version 1 is coming from the same cluster, which is coming from the GKE deployed in GKE. Second one, the version 2 is coming from the request. We are sending basically the response we are getting from the AKS, which is the second cluster. Now the same thing, same activity we'll be doing from the cluster 2, and see, we should be able to access again both there as well. So let's go ahead, exit from here. Let's copy this guy and enter again. kubectl exec-mighty multi-cluster, and we need to give our which context we want to run, which is AKS now, and command. Let's do the same thing again. Hello world. Hello. We are getting the response from the version 2, which is running in the AKS. So here also, if we run fast, we should be able to get from the both. So we can see here, it's running from, and we are getting the response from both. Perfect. So we have successfully configured the communication between those two clusters. We are able to communicate within like either of the clusters. We are able to send the request and get the response from both the instances. So here we are done with the communication, but all the things, all the setups, whatever we did it for security. Do we know really now it is secure, or it is just running on the sending on the plain text? Nothing to worry. We can test it again. So as here we can see, we are already logged into the second cluster, AKS. We are sending the request to cluster 1. So let's open a terminal and start basically capturing the packets. So this should be secured. If it is secured, it should be encrypted. So let's go and do it. For that, I'll be entering into the cluster. Okay. I'm adding it here so that we can see. Okay, I need a context of this. kubectl config get context. So Okay, it's already there, nothing to worry. So I can directly log in. So kubectl get pods and multi-cluster. Fine. So we add this one. And we want to check if this guy is receiving a request that time, if whether it is secured or not. So we'll be capturing the packets on this guy. So this is having two containers. We'll be logging, we'll be basically entering into the proxy container and we'll start capturing their packets. So let's enter into that. So kubectl exec we don't want to enter into the default container. We want to enter into the proxy container. So for that, we need to specify the container name. So here it is Istio proxy. So it means when we enter into that one, it will enter into the second container, which is a proxy container, Envoy proxy. We want to enter into that. Okay, and it is under multi-cluster namespace, and we want to run bash or sh, anything is fine. I hope so. This is fine. We should be able to get the terminal. Yeah. So we are here. Now we should be able to capture the packet. So for capturing the packet, let's run it on sudo. As we know that application port is running on 5000. So we need to capture that packet. So TCP dump. Let's listen to all basically few flags and and port 5000 so that it is not flooded with lot many packets and we should be seeing only the required packets. So for that, let's listen on 5000. Okay, is listening. When we send a request and when it is hitting version 1, that time we should be able to get here some data. Okay, I don't know once this changes. Okay, yeah. Okay, so let me make it small so that we should be able to check it. Okay, see, it hit version 1 and we got packet information here. So let's analyze a bit and see if we can read it anything. Okay, so no header information, nothing, nothing. Like all the packets are encrypted. So that proves that that setup, whatever we did, it is encrypted and secure. And we were able to communicate between the clusters. Perfect. So let's see what we did. We did this one after that. So we had deployed Istiod in the first cluster, gateway was already installed. Now we had deployed two services. So the services, how they communicate, the cluster 1 service A goes to gateway of gateway 2, and then it goes, that request goes to service B in the cluster 2. And the vice versa, if service B wants to communicate to service A, it goes to gateway of cluster 1, which is gateway 1, and then it goes to service A. So that way communication happens. Any configurations related information, if this service B wants to send to Istio, basically the control plane, that goes to again via gateway 1 only. So the dotted line, we can see it goes via gateway 1. Okay, and if service A wants to send some information to Istiod, that can go to directly because it's running on the same cluster. Fine. So this is the things we achieved after deploying the applications. After like verifying what we just verified, it is the mTLS and all, it is perfect at place and it is working as expected. So these communications are secure. We can confidently say that. Fine. So now it's time for our next part, which is authorization policy. So we will be applying L4, L7 authorization policy to basically restrict further. Like we saw this things, it is secure now. But what if we want to restrict our service only to be accessed to by a certain some other services, not by all, even to secure further? So that will be seen next. Okay, so for that, we will apply authorization policy. And we'll do the same exercise again, and we'll see whether we are able to access or not. Okay, so this is authorization policy. This is the way we write. I have written all the YAML files because to basically don't waste much time in typing, and we have all the information to explain. But, so authorization policy I have created here, like this will be applied to version 1. So match labels we are giving, like version 1, which is deployed in the GKE, the first primary cluster, it will be applicable to that. So what actions we are doing? We are allowing this service principal, basically this service or service account, we are allowing to access version 1. If we apply this authorization policy, it says that whoever is having sleep AKS service account will be able to access V1 deployment. Other than that, no one else will be able to access that. It means when we fire a request from cluster 2, like sleep AKS, if we see, the service account sleep AKS is for cluster 2, which is the remote cluster. The GKE is one is having name as sleep GKE. Okay. So if we apply this one, it means after applying this policy, we should be able to get the response from both the services V2 and V1 from, like if you send a request from secondary one, which is a remote cluster, AKS. If you send request from GKE, so we should be able to get the response from version 2, but not the version 1. So we'll verify that. So let's go ahead and apply this. So currently I'm applying this policy as a level 4, L4, because I'm not applying anything which is related to L7, but we'll see that also later. Let's go ahead first check the L4 policy. kubectl, something is wrong. kubectl apply -f, and let's apply its demo authorization. Fine. Now let's go ahead and log in, basically enter into the sleep pod into AKS, the second cluster. Okay. Now we'll send a request and we should be able to access both, which is happening as expected. Fine. Now the same thing will enter into the GKE and we'll see how it is behaving. So let's enter here and we'll start firing the request. So it takes some time. So yeah, so we can see access denied. So we will be getting the response from V2, but when it hits the V1, it will be access denied. We can see that. Terminated, access denied. So done. This also like L4 policy we applied. Now we'll try to make it even go further and we'll apply certain more informations like head. We can like put all the rest related things we can restrict, even control it. So if I enable this part, it means this service account is allowed to perform only head action. It means the get request, whenever we are sending this, by default is curl, it is a get request. So this will be denied, but when we send the I request, like head information, that time we should be able to get the information at least. And this will be denied for even like the second, the sleep container running on the second cluster. Okay, so let's go ahead and apply this. Okay, so GKE anyway, we know like it is not allowed because allowed is only for this one. Other than that, everyone is denied for V1, whoever is. So for V1, it is only this, even like only this service account is allowed, and to only perform head action, even not get will be allowed. So we'll see that. So let's enter into AKS and start sending the request. So let's wait. Yeah, it takes some time to propagate. So see, now we are getting even in cluster 2 access denied because get operation is not allowed. Only head is allowed. So what we can do for that, if you want to check that whether it's really working or not, we can send I and we see the response code, whether it is okay or not okay. So it should be okay in all the cases. So 200 okay we are getting, 200 okay. So always we should get 200 okay. So now we applied L7 authorization as well, and we are able to control that. So perfect. This is the thing. So L4, L7 also we achieved. We tested it successfully. We controlled it. So yeah, that's all. This is all for this session. If you have any question at any point of time, please feel free to contact us at contact@imesh.ai. If you need further information, book a demo with us at contact@imesh.ai. Debasri, over to you.
Yeah. Thank you. Thanks a lot, Ravi. So I think we have covered most of the pointers. So in case we can wait for we have already crossed 1 minute. Sorry, 6 minutes. If there is any questions, we can take I think one or two questions. Otherwise, we'll close this session.
Okay, Omar, I can see is telling something.
All right.
Hello, sir.
Yes, Omar.
Okay. Well, thank you first of all for this workshop. Honestly, I have a question. I already did all this configuration by
Mhm,
myself, but I was doing that on two VMs.
mhm,
So I created two mini cube
mhm,
clusters,
mhm.
each one on Scaleway VM with public IP, and I want to establish the same thing that you did earlier.
Mhm.
But the problem that I get response from only one cluster. It means that I only get V1 from cluster 1 and V2
Got
from
it.
cluster 2.
Yeah, so
So
as I mentioned this one, like we need to apply the credentials at the right time. If we follow the guide in the Istio, it is applied at the end, which doesn't work.
yes, I followed correctly the issue documentation for multi-cluster in
Yeah,
different
so
languages.
it won't work that way. You try whatever I did it today that way. Like you apply the credentials of the cluster 2 before applying before installing the east-west gateway in a cluster 2, and then try it. If you get any issue, let me know again. We can check it.
Okay, I will do that, and I will contact you to further details if I can.
Yeah, sure.
Thank you, sir.
Thank you.
All right. So thank you. Thanks a lot, Umar. I think we have reached to the end of the session. We'll close it. And stay tuned. We have many more webinars coming up on securing banking applications, e-commerce applications, and setting up Istio on AWS and GKE. So there are interesting, pretty much interesting webinars coming up. Stay tuned. Have a wonderful day and bye-bye.